Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be talking, inshallah, about the revision of the basic KNX certified course. We talked before about the KNX basic certified course. We know that it is 2 parts, theory part and practical part. Today we'll be trying to wrap up all what we have learned in the theory part. So in something like half an hour, we'll try to check what I've learned in the theory part. The idea about this revision is to remind you about the important topics in the theory part. So let's say you've already taken the KNX Basic Certified course, and now you want to remember what was important, then this revision is for you. Maybe you already took the course and you need to take the advanced course, so you need to wrap up what happened in the basic course. Also, this revision is for you. If you did not have the time not to take the basic course, but you've taken, let's say, a preparatory course, which is available on our online page for free, then also this one will be good for you. Okay. Then we'll talk about, inshallah, about the practical part. We'll have some videos also on the same playlist about the practical part, also to get you somehow knowing what you're going to do in the practical part, or also as a wrap-up what happened in the practical part. So this whole package is for you to review what we've taken in the theory part, and also the next videos will talk about what we've taken in the practical part. My name is Wissam Tawfi. I'm the certified KNX basic. I'm the KNX certified tutor from my home future, and I will be happy today to go with you through this part. This part is also available in Arabic, but this one is in English. So starting with, I always want to start with this slide. Okay, it's about connectivity. Because KNX is a very popular protocol, a very important protocol to learn. However, for some projects, KNX will be a bit hard to implement. So you have to learn when you need to implement KNX as a protocol, or when you need to implement a different protocol, like a wireless protocol. So normally, if you have a place which is working under construction, then you can go with KNX. However, if you have a place, let's say a villa, an office, a house, which is furnished or ready to move in, so you don't still have the time to put the cables for KNX or to review the electric cables, then KNX would be hard to implement because you need to do a lot of changes in the interior of the house. In this way, I recommend that you can go with something wireless. I always recommend, if you're going wireless, to go with Z-Wave. Okay. Both Z-Wave and KNX are open protocols, so they have a lot of companies working with them. When I can implement Z-Wave or maybe ZigBee or wireless protocols in general, when I have a small to medium project, which cannot have cables in it. Can I still implement KNX in these projects? Yes, you can do. However, KNX is mostly built on TP, with the wired protocol, the wired cable, which is a little bit hard to implement as a purely wireless protocol. Okay, but KNX is more suitable for projects which we have medium to large projects under construction, when I have to implement an integration with BMS, which is the building management system, or GRMS, which is the system for hotels. So this is a good thing about the KNX. We have what we call KNX association. We talked about this in the basic course. KNX association is the association, okay, responsible for all KNX activities. So what KNX association is doing, they are doing marketing, doing the ETS of the software that we do for KNX to integrate or to program KNX devices. They do checking and putting the implementation technical development for the KNX manufacturers who are going to manufacture KNX devices. So KNX association will not do any manufacturing, okay, but they give the mandates and the instructions, so the KNX manufacturers like ABB or Schneider or whoever can start manufacturing and doing devices under the supervision of KNX association. Also training, they don't do training directly, but they do training via training centers like us under their supervision as well. The unique value of KNX, so what makes KNX now a very famous protocol, that it's an open protocol. So you have something like 500 companies doing devices for this protocol. So you will never get a device needed and you cannot find, because if ABB is not doing a device, then maybe Schneider is doing it. Then maybe a different company in Italy is doing that. Maybe a company in China is doing that. So a lot of companies are competing together on the quality and on the price to give you the best device to work for your project. Okay. Also, it's one single configuration tool, the ATS. So you have to learn only one tool, the ATS, or one protocol, the KNX, which allow you to implement a lot of devices in your project. It has different media, so I can connect KNX device using the TP, the twisted cable, the twisted pair cable, or I can also connect them using IP protocol. In this case, like via Wi-Fi, fiber optics, anything like that. And also there is KNX RF, which is an RF protocol, radio frequency protocol, which also will work with me to connect my device as well via wireless connection. And all of that was covered on the KNX Basic Certified course theory part. Once you're done with the KNX course, these are the partnership benefits for you. You will be recognized as a KNX official partner. You can put the KNX partner logo on your email and on your CV. Also, your name will be placed on the KNX Association website, and you can put your company on the KNX Association website. So worldwide, it's a certificate which is worldwide recognized and will allow you, of course, to put more momentum in your career and in your projects that you are having. Let's talk about how KNX wiring is working. In this part, this one, this is a normal way. This is how our houses, if you don't have any smart home, the cabling is like that. So you have the neutral cable, which is coming from the DB to the load. This load might be a motor, maybe a lamp, chandelier, and then the line cable, okay, which is going to the manual switch. And then the connection between the manual switch and the load is directly from the switch to the load. And whenever I want to change anything, so if I want to change that this button is controlling a different lamp, then I have to take off this cable and put a different cable. So the connection between the switching, the devices, and the loads is a physical connection. I have to unscrew my device and put a different cable, get the connection done. What KNX did it is to separate that, and this is what all smart home devices did. But KNX is doing it in a different way. So KNX said, okay, I will separate the connection between the user interface, which is the keypad, like this keypad as an example. Okay, I'll separate from the connection of the load. So no more this switch, which is the user is controlling. No more this will be working directly with the load. This is what happened here. So we have here a keypad, which is the user will use to control his devices, but is not connected directly to the load. Okay, so there's no direct connection here to the load. Actually, what's connected to the load, it's what we call actuator, which is a device, maybe a relay switch, KNX relay switch, which is connected directly to the load. So the line cable is already going same way from the neutral is going same way to the load, as you can see that. Same connection like above. Okay, but the line is not going to the switch anymore, it's going to this KNX actuator or switch. This KNX actuator is connected to the lamps. And then there are different keypad here, which the user will see. This keypad is connected to the actuator via KNX, or connected to the system of the KNX via cable KNX. And this way, if I need to change what this button will do, I can do that by programming, saying that this button will control this lamp, okay, which will be controlled via this channel and the relay switch. This is how it's normally working now. So any connection between the load and the actuators is physically there, but not affecting my user experience, because user experience will be depending on the programming I'm doing. Okay. The minimal structure of KNX is normally a very simple one. You have a load, which might be a lamp or a motor, okay? And it needs to be connected to an actuator to be controlled. So an actuator is a device that will control the load. And then you have a keypad or a sensor that will send a command to this actuator. So you also have here a keypad or a sensor, or maybe a touch screen that will send a command to this actuator to turn it on or off the motor to turn it, make it up or down, something like that. And for this system to work in KNX, you have to put two things additionally. You have a connecting media. In this way, it is the KNX cable, the green one. Okay, so all KNX devices should be connected via a KNX twisted pair cable. And you also need a power supply, which is a KNX power supply. We'll talk about that in the project design in detail. So the minimal structure I have in the KNX cable is the power supply, and then the devices I have. In a minimum structure, I have an actuator connected to a load, and a sensor or a keypad, which the user will use to control the load. In a case, if you are wondering how to connect KNX devices together, then you can connect them together in a tree structure or a star structure. So all devices will go from the power supply, and then you can connect together via the KNX cable from one device to a different device, or maybe from one device to different device. This is a star. And in this line segment, we call it a line segment, you can have up to 256 devices connected in a single line segment. This line segment can be up to 1,000 meters. And if you want to increase the length, you need to put something that we call a line repeater. A line repeater is something that looks like that. So it's a device that will put in your system, connect two lines together. It can act as a repeater. Later, we'll talk that it will also can act as a line coupler, where I can have more lines together. Okay. So maximum on one line segment, I can have 256 devices connected together. Fine. However, this is not enough. You've seen already in the basic course, and we'll talk more about this in the advanced course, that I can put up to, I can connect lines together. So I can put up to 15 lines together to reach an area. Call it an area. So an area is 15 lines together. And I can connect up to 15 areas together. And I do this connection via the line coupler. Find this, because this is a revision, so I'm not talking about that in details, but you'll find this in the basic course files, and we'll talk about them also in the advanced course, inshallah. But I can connect up to 15 areas together. Each area will have 15 lines. Each line will have up to 255 devices, because the line coupler is connected there. Okay, so you can end up with a system that can have around 65,000 devices or more than 65,000 devices connected together. Okay, so you can have a project with a very large number of devices connected together. There is something that we call individual address. So this address should be a unique address for each device in KNX topology. And this address depends on the location of the device in the topology. So the device might be located in one area or one line and the number of devices. So if I have, let's say, a simple topology where I have one line and one area, then my number will be one area, so one line, so another one, and then the number of devices within this topology. If I have more areas, then I have maybe area 1, maybe area 2, maybe area 3. Each area might have different number of lines. So an area might have 5 lines. In this case, I have area 1, so 1, and then maybe line 1 or line 2 or line 3 or line 4. So it will be different depending on the location of the device. What you need to know about this address, which we'll use in the practical part a lot, this address, we do it in the beginning, so you program it in the beginning. It should be unique on your topology, okay? And normally we are not using it during our operation. We use it in the diagnostic part, we use it in the programming part, but the topology itself, that the programming itself will not rely on the individual address, but will rely on something that we call group address, okay? What you need to learn about this address also, that it will have a unique number, and for a normal device, it will not end with 0. So a device number will start from, let's say, 1.1.1 up to 1.1.256 if you want, if you don't have a line coupler in this direction. Okay, 255, sorry, not 56. 1.1.255. Okay. Another address, important one, that we call it a group address, and we'll talk about this in details in the practical part. The group address is what I use to connect devices together. This is what I call a group address. So if I need to connect, let's say, an actuator with a keypad, I need to join something that we call a group object from this actuator to this keypad together using what I call a group address. And we'll talk about this in details. A group address can have different naming structure. So you can have a free structure, okay, or a categorized structure. A categorized structure might be a 3-level structure. So I have a main level, then a middle level, then sub, where I put the group address. Or I can have a main level, 2-level structure, so main level and sub level, and or a 3-level structure. Why should I use a 3-level structure or 2-level structure? To make it categorized, to make it organized, okay? Instead of have all the group address together listed like that. So it's something like what you do in your normal life when you have folders and subfolders, okay? And we'll talk about this in detail in the practical part. This part will not be very clear unless you do the practical. What kind of KNX components I have? We have actuators. So these are the actuators, which will control the load. And actuators normally come, with a type of load. So a dimming actuator will be different than a normal relay actuator. It will be different than a shutter actuator, okay? And they normally come with number of channels. So maybe 4 channels like this one, okay? Or maybe this looks like a 12 channels. And an actuator, a typical actuator, will look like that. So this is a typical actuator. This is an 8-channel actuator, relay actuator. So you'll see, and we'll talk about this in the practical, that it has something called local buttons. And this one is an 8-channel actuator. Actuator will depend on the load. And then we also have the sensors or the keypads. So might be a sensor, might be a keypad like that, okay? And will normally depend on what I'm going to control. So a keypad that I'm using to control an on-off might be a little bit different if I'm going to control an AC, an air condition. Or a sensor, like a motion sensor, a presence sensor, a draw window sensor, depending on the action I'm going to do with my system. Then you have something that we call system device. This is like a power supply, a gateway, maybe a line coupler, an IP router, and finally we have a visualization, which might be an mobile app or something like that. Let's talk about this in more details. So let's talk about a project. Let's say, oh, I have a project today, and I want to talk about the project, what I'm going to include in this project. First, I need to find out what is the project scope. So in this case, I need to find out that maybe the owner or the project scope that I need to control lights and shutters. Okay, this is the project scope. This is number 1. Then I need to check what is the actuators I'm going to use. The actuator selection will depend on the shop drawing. So I put shop drawing, which is a notepad file, showing the number of loads and the type of loads. Depending on the number of loads and type of loads, I can get the number of actuators. Okay. So how could I number the actuators? I need to find here is the type of load. So a light actuator is different than a shutter actuator. Then I need to find out how many numbers or circuits in for this load. So if I have a light actuator, let's say 16 channel, 16 circuits, then I need to get a light actuator that will work as 16 channel, something like that. Okay. So normally I fill in an Excel file like that, where I have the number of loads I have, number of lights. Okay. So I have, in this example, I have number of circuits, 14 circuits, which is 16 ampere on off. And then I have 9 circuits, which is 10 ampere on off, and go like that. In this way, I have to fill in the number of actuators I need. In this case, I need at least a 14-channel actuator, okay, which is doing an on-off. Then I go to my model and I start putting the actuators I need. This way, I got the actuator. Okay. After that, I need to get the keypads. The keypads I can get using what I have with the logic or with the end user. So I sit with the end user and I start talking about the logic. Do you need one button to control the lights, or you need one button to control some other lights? Depending on that, I can get the number of buttons in the house, in the room, or in the keypad, or maybe I can use touch screen. So I need to sit with the user and find out about that. For the sensors, it depends on the scenarios the user wants to do. So if the user wants to have a scenario where I am in the house, and when I leave the room, the light will go off. In this case, I need a presence sensor or a motion sensor to make sure that when I leave the room, the signal will go from this motion sensor to my system, so I can turn off the light or turn off the AC. So sensors will also depend on the action that the user want to have. After that, I can go to the system device. The most important device in system device is the power supply. And I calculate the power supply based on the number of devices I have and how much power each device is consuming. So each KNX device will have a a specific consumption of power. Okay, normally it comes with milliampere, MA. And then I need to sum up all the power consumption of all the devices I have on one line. And then I need to get a power supply that at least give the same power. So if I have, let's say in my project, let's say I have 30 devices, each one is covering, let's say in average 10 milliamperes. So I have 300 milliamperes. So I need to get a power supply that will at least give me 300 milliamperes. Normally I put a risk factor. So I get a little bit bigger one. So in this case, I can get a power supply which is 640 milliampere. Okay. To cover also my future expansion. If I need to change something, I don't need to change the power supply. Then visualization, and it depends on a lot of things. And how many devices or what are the other devices I need to integrate in my system. Sometimes I need to integrate devices like intercom, like cameras, like sound. Okay, and then the server and visualization will do this integration via the IP network. I need to integrate Alexa. This way, I need to choose the server carefully, and also the mobile app. Some mobile apps will give you the power to tailor the application itself. Some mobile apps are very specific, are very strict in their design. This way, I need to check which mobile app I need to use and which server or gateway I need to use. We'll talk about visualization and servers more in the advanced course. But now you have what you have in the project. Okay, so this is what you have in the project planning. You need to get the number of circuits, loads, and types. Okay, and then you determine the number of actuators, then determine the location of sensors, then calculate the power supplies, and then the obstruction ETS. So later, inshallah, in the practical part, we'll have a simple project where we do the programming of the project together to see how we can connect the keypad to control lights or control dimming or control shutters together, inshallah. If you have any question, let us know, and I will see you, inshallah, in the practical part where we talk more about all what you are seeing now in here. And my name is Wissam, and hope to see you soon, inshallah. Salam alaikum.